Welcome to the Bodhi Academy. My name is Amisha Kulaso and today's video is on the chapter Rational Numbers of class 7th. So to begin with, let's understand what the term rational means. So when I say rational, the term rational is derived or it is known from another term that we already know, that is ratio. So now when I say ratio, say we have 2:3. In this case, this is the ratio. Now this same ratio we can write in the form of fraction, that is 2/3, and this fraction is known as rational numbers. So a rational number is defined as a number that can be expressed in the form of p by q, where p and q are integers and q is not equal to 0. So see here, now we can say that this rational number is expressed in the form of p by q. So here p is equal to 2 and q is equal to 3. And one thing we need to remember is that q is never equal to 0. So thus 4 by 5 is a rational number. Here p, that is the numerator, is 4 and q, that is the denominator, is 5. So now, is 3 by 4 also a rational number? So it's obviously yes. Why? Because 3 and 4 are natural numbers. So now basically rational numbers can have natural numbers, they can have whole numbers, and they can also have integers. So it is basically a combination of all these types of numbers. So now then, how about the decimal numbers like 0.5, 0.33, etc. So now when we talk about decimal numbers, we know that decimal numbers, they are, so decimal numbers are derived from fractions or rational numbers. So now when I say they are derived from fractions or rational numbers, now say we have 0.5. So 0.5 is basically what, if we have to write it in the form of fraction. So 0.5 will be equal to 5 divided by 10. So basically if this I divide, say there is only one 0 here, so the decimal is right here. So if I shift this here, we get 0.5. So decimals are also rational numbers. Same way, say we have 333 divided by 1000. So here there are 3 zeros at the denominator, so if we shift this decimal thrice, 1, 2, 3. So we get 0.333. So this tells us that decimal numbers are also rational numbers. So yes, decimal numbers are also rational numbers. Now let's talk about the numerator and the denominator. So now in p by q, the integer p is the numerator and the integer q, which is not equal to 0, is the denominator. So now thus when we say minus 3 upon 7, the numerator here is minus 3 and the denominator is 7. So now this is the basic concept that they are telling us, that p and q are two integers. They can also be natural numbers, plus p is the numerator and q is the denominator, and q is never equal to 0. So now in this simple example, they said that we have minus 3 by 7. So here obviously the numerator, that is on top, that is p, is minus 3 and q is given as 7 here. So now let's mention 5 rational numbers, each of whose. So first one is saying that, it says a numerator is a negative integer and the denominator is a positive integer. So we have to write 5 rational numbers whose numerator are negative and denominators are positive integers. So now we can take simple examples like say minus 3 by 5, then we can have minus 4 by 7, we can have minus 5 by 11, and say we have minus 9 by 13. So now in all of these cases, one thing common is that our numerator is negative. So we have minus 3 here, minus 4, minus 5 and minus 9 in the numerator, and all of our denominators, that is 5, 7, 11 and 13, are all positive integers. So now moving ahead, next we have to write a numerator is a positive integer and denominator is a negative integer. So now let's take the same example as above, and now here we just have to write the inverse of what we wrote on top. So say this is minus 3, we'll write it as plus 3 and minus 5. Moving ahead, we'll write as 4 and minus 7, 5 and minus 11, and say 9 and 13, minus 13, sorry. So here what we have done is just the reverse of what we did in the beginning. So here all the denominators are having a negative sign and all the numerators are positive integers. Now next, numerator and denominator both are negative integers. So now both the numerator and the denominator is going to have a negative sign. So same examples we shall continue with. So we have minus 3 upon minus 5, minus 4 upon minus 7, minus 5 upon minus 11 and minus 9 upon 13, minus 13. So in this case our numerator and the denominator both are having a negative sign, and so therefore our numerator and denominator both are negative integers. Now last we have the numerator and the denominator both should be positive integers. So here we'll simply write, no sign will be involved in this one, so it will just be 3 by 5, 4 by 7, 5 by 11 and 9 by 13. So here both our numerator and denominator both are positive integers. Now next question that would be coming to our mind would be, are integers also rational numbers? So now when they say integers, they are talking about single digit numbers. Like on the number line we will have, most of the time what we see are like numbers like, we'll have 0, we'll have 1, 2, 3, and this side will have minus 1, minus 2, minus 3 say. So now these are single digit integers. So now the question here is, are these single digit integers also rational numbers? So here the answer will be yes. So now how? Now previously what we have said is that rational numbers are in the form p by q, and q is not equal to 0. Okay. So now say I have minus 5. Now minus 5 is just a single digit number. There is no upon happening here. But now when we write minus 5 by 1, it is of course the value of this will still minus 5, and yet it is in the form of p by q. Therefore minus 5 is also a rational number. Okay, so any number may be a single digit number. If we write it upon 1, it will still remain, its value will still remain the same. So in that case we can still write it in p by q format, and yet it becomes a rational number. Now say we have 0. Now here one thing we have to remember is that q can never be 0. That is, in the denominator we can never have 0 as the denominator, but we can still have 0 in the numerator. So if I write say 0 by 2 or I write 0 by 11, these are still valid rational numbers. So here our 0 is p and our q is 2. So we have still p by q happening here, and we also made sure that q is not equal to 0 over here. So this answers that are integers also rational numbers? Yes, they can be rational numbers. Now let's move ahead to a concept of equivalent rational numbers. Now when I say equivalent rational number, a rational number can be written with different numerators and denominators. For example, consider the rational number minus 2 by 3. So now what we mean here is, basically to understand rational numbers, it is like your value will be same. Value will remain same, only will use different numerators and denominators. Okay, so now say we have minus 2 by 3. So when I say minus 2 by 3, now we can write minus 2 by 3 in another form. So say I multiply this numerator and denominator by 2. So I'll get here minus 4 upon 6. This if I divide again, this minus 4 by 6, say 2 2s are 4, 2 3s are 6. So I get back my value of minus 2 by 3. Now such numbers, so here minus 2 by 3 is also equal to minus 4 by 6. So such numbers are called as equivalent rational numbers, where I wrote the numerator and the denominator in a different format, yet my value remains the same. Let's take maybe another example. Same, I will continue with minus 2 by 3 only. So minus 2 by 3, say now I multiply it with minus 5. So I'll get here 10 upon 15. Here I'll get 10 upon 15. So again when I cancel out this, I'll still get 2 by 3. But in this case I'll get 2 by minus 3. So which is also equivalent to 10 by 15. Okay, so now if we have understood that concept, now let's try. So now we have proved that what are equivalent rational numbers. They have the same value, but their numerator and denominator can differ. So now let's try to fill in these boxes. So 5 by 4 is the same value that we have to get after substituting any numerator or denominator in the given boxes. So now how do we do that? To start with the first one, so we have the value of 5 by 4 equal to, we don't know the numerator, and here we have 60. So what we are going to do here is simply find if we divide 16 by 4, we'll get obviously 4 here. So this 4 we are going to multiply here. Okay. So let's go up. Yeah, so 5 by 4 equals to this box upon 60. So here we'll get, so here we know that 16 if we divide by 4 we'll get the answer as 4. So here now what number if I take, will I get 5 in this section? So I can take here, okay, so we have 16, so we'll get here 4, and we can take here 20. Okay, so now, sorry, here it will be divided by 4. So here we'll have divided by 4. Okay, and this divided by 4. So now in this case, if I divide 16 by 4, my answer will be 4, and if I divide 20 by 4, my answer will be 5. So here we have got back the value. So in this case, this first box will be having, the first box will be having here 20. Okay, now let's fill the second box. Okay, so now we have the second box. So we have 5 by 4 equals to 25 upon this we don't know. So again, if we divide 25 by 5, we'll get 5 here. So this number will be divided by 5 here. So now if we divide 5 by which number, we'll get 4. So obviously it will be 20. So if I divide 5 by 25, I'll be getting here 5, and if I divide 4 by 20, so I'll get, if I divide 4 by 20, I'll get 4 here. So we'll fill up this place by 20 there. Okay, so similarly we can find the last one over here, and that's how we fill in the boxes. So now moving ahead, how now previously here we saw, see in this example what we saw was, in the first case we got a value of minus 2 by 3, and in the second case we got a value of 2 upon minus 3. Okay, so now here the negative sign that is there, here in the first case it is for the numerator and here it is for the denominator. So the next question that we need to ask ourselves is how are, like say now here we have 10 by minus 15 and minus 10 by 15, same or equivalent? Are they same or are they equivalent? So when I say this, let's say I have 10 by 15. Okay, so now what I do here is, let's read this statement. By multiplying the numerator and denominator of a rational number by the same non-zero integer, we obtain another rational number equivalent to the given rational number. So now what they are saying is, here we have to, the numerator and the denominator, we have to multiply or divide it by a same non-zero integer. So we have 10 here and we have minus 15 here. So say I divide this by 5 here, minus 5, and here also by minus 5. So this will give us what? So if I divide this, I'll get 2, that will be minus 2, and this will give me just 3. So now in this case I have got minus 2 by 3. Now let's take another one, 10 by 15 equals to, say now here I take, here let's take here 12, minus 12 by 24. So now here in this case I have 12 upon 24. This I divide by 12 again, and this I divided by 12 here. Okay, so now here what I'll get minus 1, and I'll get here 2. Okay, so now let's look at these numbers. Now if this same number I had to divide it by a positive 5 and a positive 5, the answer here would be inverse. Okay, say I had to, okay, so say I make it positive. Okay, in this case what I would get was 2, and I would get here minus 3. So now these two numbers are equivalent. So when we get such answers, what we do is, instead of writing the sign in the numerator or denominator, we write it somewhere in between. So we'll write this answer as minus 2 by 3. So see here, the sign is neither in the numerator nor in the denominator. It signifies that this sign can be either in the numerator or the denominator, and it will still be the same rational number. Similarly here, if I take, say now, I make this as minus 12, minus 12. So here again I'll be getting the same thing. I'll get 1 upon 2. Sorry, minus 2. So in this case also I can write it minus 1 by 2. Okay. So we have proved that when the sign is either in the numerator or denominator, they still be equivalent numbers. Okay. Now let's understand positive and negative rational numbers. So say I have an example. So consider 2 by 3. Okay. So now here we know our numerator is all positive and our denominator is also positive. So now such numbers are called as positive rational numbers. Okay. So such numbers where the numerator and denominator is positive, such numbers are called positive rational numbers. Now say we have minus 3 by 5. Now here our numerator is negative and our denominator is still positive. So in such cases, such numbers are called as negative rational numbers. Okay. Now say we have a number like, say we have now 0. So now the question is 0 a positive or negative rational number? Okay. So numbers like 0, we say they are neither positive rational numbers nor negative rational numbers. Okay. So now let's say we have, let's take an example. We have, say, minus 3 by minus 5. Now, is this a positive or negative rational number? Okay. So now here what we can say is that we have minus 3 upon minus 5. This now if I multiply it by minus 1 and minus 1, I'll get, this will become positive. So I'll get 3 upon 5. Minus into minus becomes positive. So this is a positive rational number. Okay. So we have positive and negative rational numbers, and 0 is neither a positive nor a rational number. And when we have, say, negative rational numbers in the numerator and denominator, we say that they form the positive rational numbers. So in today's video, what all we saw was, we understood the meaning of rational numbers, how it was derived. Then we answered questions like, are decimal numbers also rational numbers? We spoke about the numerators and denominators in the rational numbers. We also answered the question that integers are integers rational numbers. We learned the equivalent rational numbers that have the same value but different numerator and denominator. We learned to fill in the boxes and find the values of numerator and denominator. We also justified how 10 upon minus 15 is same as minus 10 upon 15, and we learned finally the positive and negative rational numbers. So thank you so much for watching the Bodhi Academy. Please don't forget to like, share and subscribe. Thank you.